And welcome viewers to the Daily Space Weather. The plasma filament we were looking at yesterday is still there, dancing around in the northeastern limb. This is an SDO view from the Solar Dynamics Observatory, 211 angstroms ionized iron. And we've got a degrading sunspot. We'll get to it in a minute. In fact, our next frame will get to it. We do have a coronal mass ejection watch in effect. The likelihood of solar flares has gone down. The likelihood of a coronal mass ejection, not so much. So this one's taking its good old time. And if you see our coronal mass ejection watch turn into a warning, it's because it's occurring or has just occurred. Anyway, here's ionized helium. And sunspot 2857 is the only sunspot group. It's looking like it's going to degrade to alpha class if I had to forecast. And maybe I do. I don't know. Leave us a comment if you think I have to forecast. Here's a colorized magnetogram, and you can see these fields are getting closer together, making it more likely, in my opinion, for them to cancel out. So you can see the way these fields are migrating toward each other here, especially at the end of the video. It looks like the leading umbra is starting to evaporate. Don't be surprised to see this recategorized as an alpha class sunspot. That's the cause for the reduction in solar flare likelihood. Again, likelihood of coronal mass ejections hasn't gone down. Here's a full disk view in the original wavelength we showed you here, 211 angstroms. And a large portion of the Earth-facing disk is indeed consisting of coronal holes right now. Here's some more great imagery from the Solar Dynamics Observatory. 171 angstroms. Another one of the emission spectral states of iron. It's ultraviolet light. And we'll save some more great imagery from the Solar Dynamics Observatory for the end of the video. The radio flux has come up to 74. Here's a one-year chart of the radio flux from Solon.info. The black line's the radio flux. No space weather warnings or anything. No geomagnetic storms or unrest forecasted. We can expect a high-speed wind from some coronal holes. Current conditions are slightly elevated. We'll get to it in a minute. First, global seismicity. Still showing up as high here, according to Volcano Discovery. This is a 90-day bar graph, and you can see the recent uptick in seismicity here. So there was a 6.9 in the past 24 hours. That's the largest quake since yesterday's video, and that South Sandwich Islands region is quite active. Let's zoom in and show you how many swarms have just happened in the past 24. How many quakes in this swarm have happened? Check it out. Lots of earthquakes there, including this one on the eastern side of this ocean rift. And indeed, the South Atlantic Ocean plate side of the boundary here, with the Southeast Pacific Basin plate there. And consulting the list, we're just going to scroll up here. What is this one? A North Korean quake at an estimated depth of 550 kilometers. Only a 4.3 magnitude, but a very deep quake there according to estimates. Also, the South Indian Ocean here saw a quake right near the equator. That was a 5.0 magnitude. Vanuatu saw a deep quake at 5.1 magnitude there, 161 kilometers estimated depth for that. A couple high 4 magnitude quakes in western South America. And let's look at volcanoes next. This imagery here, by the way, is Shiveluch from August 11th, so some glowing rock falls showing there on the Volcano Discovery Volcanoes Today page. Karimsky, currently erupting on that peninsula, the Kamchatka Peninsula. Explosive activity from Karimsky's produced an 8,000-foot ash plume. Shiveluch, not too far from Karimsky, also erupting. The active lava dome, Collapsed Dome Dolphin 2. The active lava dome in the area of Collapsed Dome Dolphin 2 continues to grow with magma rising into it. More and more unstable hot lava material is accumulating and prone to collapse into hot incandescent rock falls. Also, steam activity. Steam activity also happening there at Shiveluch. Chirinkhatan in the northern Kurils, south of the Kamchatka Peninsula, in between there and Japan. 14,000-foot ash plume from Chirinkhatan as it explodes. Fukutobu, Okanoba. So some pumice swirling around in the Pacific Ocean. This is an underwater seamount here. And pumice has a tendency to float because of its high gas content. Mount Ibu exploding, 6,000-foot ash plume over Halmahera. Merapi, flight level 120 as it explodes, or at least erupts, producing a flight level 120. Semeru, flight level 130. Popocatépetl dispersed its ash over Mexico, fertilizing the area in the central part of the country. Fuego, exploding, 15,000-foot ash plume from Guatemala. Colombia, 19,000-foot ash plume produced by Nevado del Ruiz as it explodes. Revenador, volcanic emissions have dispersed in the nation of Ecuador. Sabancaya in Peru, explosive activity continues there. Sporadic puffs of volcanic ash have produced a flight level 250. A 25,000-foot plume of volcanic ash is a great reminder to not pole vault the caldera, something we talk about regularly at smAsho.com. Thanks to all of our supporters. Click our links, support our channel, press like, subscribe, share with your friends and foes on social media. Thanks to our patrons. Perhaps consider becoming a patron. And if you didn't see our posts yesterday, patrons, please go have a read. We included the breakdown for the upcoming subscription services at smAshomash.com. So go have a read about that. Patreon.com/smAshomash. Next, looking at the GOES X-ray flux to see no major flares. That's the 3-day chart, and we haven't seen anything beyond a C-class flare for quite a while. No spikes in the proton flux here, as measured by the same satellite, the GOES 16, a real workhorse. Here's the GOES magnetometer over the past 3 days, and this is the South Pole current sheet magnetic regime being measured, as Earth is now in a South Pole oriented current sheet. We'll show you that on the next frame. And it looks like there's some additional magnetic turbulence coming here as we see, oh, okay, South Pole current sheet looking like it's going to remain there, at least based on the last image. Anyway, this hour, 1 hour and 1 minute old from when we recorded the video. Keep in mind the magnetic environment can suddenly change. Here's the line of sight ecliptic plane field plot. Basically the same data, but from Earth's perspective instead of the top view. And you can see that blue line swinging around as a result of material largely in the northern hemisphere, pretty much entirely in the northern hemisphere. And here's our coronal hole line of sight plot. And you can see quite a bit of coronal holes here. Some of them perhaps not even showing up. And I would expect to see a coronal hole high-speed stream from this North Pole-oriented coronal hole in about 48 hours. Maybe 56 hours. Something like that. This image also shows the sun's B field in blue. Those blue potential field surface source lines are the sun's B field, the field that goes through the magnet. We'll show you the Earth's B field in a moment, or changes in it. So here's our flare monitor and detected sunspots. Again, we are expecting to see sunspot 2857 to degrade to alpha class, reducing the likelihood of solar flares. The likelihood of coronal mass ejections not being reduced. The CME watch still in effect. There's going to be a CME in the Earth vicinity. Whether it's Earth-directed or not is another story. KP index, a measurement of global geomagnetism, currently only at 1. Geomagnetic chill conditions. Let's look at the real-time solar wind. Pretty uneventful here over the past 24. Current solar wind conditions are a density of only just under 4 protons per cubic centimeter. Solar wind speed still elevated here from coronal hole wind, 465 kilometers per second. We've already seen an increase in the electron flux. We'll get to that in a minute. Next, looking at magnetohydrodynamic pressure as modeled by the Space Weather Modeling Framework. It's 4 hours of the geospace. And we're expecting to see fairly homogeneous pressure here as we see a fairly homogeneous solar wind. Looks like a slight reduction here on the bow shock side, the side facing the sun, which would be to your left, in the past 2 hours. Ground magnetic perturbations are next. Geospace delta B are changes to Earth's B field, and we're not expecting to see many. And probably a reduction in this as well. It helps us to tie the physics together. If you look at the real-time solar wind and the geospace magnetosphere movie and the ground magnetic perturbations in succession like this, it helps you to understand the induction caused by the incoming solar wind. Next, looking at a diagram of the solar system here. We like our viewers to be oriented and know where they are and where they're going. We'll advance this 1 week to do just that. There's where things will be on August 24th, 2 days after the full moon. And next, a star chart. So now we're on in-the-sky.org. The sun's just rising. Jupiter's just set. Today the sun will pass through Gemini and Taurus and right next to Aries. I like to face my star chart to the south, since I'm currently facing the south, and so is my sofa. So when I watch this in the living room on a larger screen, I'm facing the same direction I'm facing when I made the video. There's some behind-the-scenes stuff for you there, folks. And let's continue on to briefly talk cosmology. This cosmology segment once again is integrated into the Daily Space Weather video. Check our playlists. There are lots of other cosmology segments, over 200 of them. youtube.com/smashamash/playlists. What about ripples in Saturn's rings reveal, quote, fuzzy and, quote, nature of gas giant's core? Now, I've got different ideas as to what the core of Saturn is made out of, but I'm just going to let the article scroll here, as it looks like the wobbling core may be affecting Saturn's rings. So things going on inside the planet, maybe some sort of a proportional representation of what's going on in the rings. And of course, just to give you some idea what I think that Saturn contains superionized materials. I'll talk about that quickly in the next frame here. Here's a little animation of the way Saturn's rings have a wobble, which looks like it may be associated with the wobble of the core. So if Saturn's made of superionized materials, folks, I think that's a much better hypothesis, as when you get to millions of atmospheres of pressure, things like certainly hydrogen and water turn into superionized materials, where the nucleons become constrained into a vibrational lattice structure, a crystalline lattice structure, which has completely different properties to non-superionized materials. And in superionized materials, the nucleons are constrained. However, the electrons are free to flow as in a metal. And this is very interesting. This, I believe, is the frontier of material science, perhaps even things like energy production on the planet. To quote Robitaille, if we can harness the power of lattice-constrained fusion, it will change the course of human history. So, nonetheless, this is interesting regardless, because if there's some sort of a relationship between the wobble of Saturn's core and the ring system, perhaps it gives us insight into how the ring system formed. If you want to read about superionized materials, here's some information on Wikipedia about superionized water. Did you know that when water reaches a few million atmospheres of pressure, the oxygen nucleons turn into this cubical lattice structure, as shown in this imagery here? The red spheres here represent the oxygen nucleons, and the white spheres represent the liquid metallic hydrogen, which just sloshes around within this crystal lattice structure. And it seems to behave like a metal, most likely. This has been created in a lab. If you want to read about ionic water, feel free. This is a plasma, but again, it's a single segment plasma. As again, the nucleons are condensed matter. They are constrained to a crystalline lattice structure, while only the electrons are considered a plasma. That's why we call it a single segment plasma. And again, the superionized materials are, I believe, indeed the future of material science and perhaps energy production on the planet. I've been forecasting free electricity coming for a while now on the channel, and I'm not going back on that forecast. Today's astronomy picture of the day, you can view it yourself at apod.nasa.gov, is the Ring Nebula. Now, at the center of the Ring Nebula is a star that obviously didn't die. It's still ionizing the gas toward the center of this, and this is believed to be a sun-like star which is in some sort of a different stage of its stellar evolution according to the concordance model of stellar evolution. And you're looking at probably different chemicals here in this Ring Nebula's structure. I'll just scroll down here so you can get the caption. Feel free to pause the video. We're moving on. And we're not picking any random numbers or anything. We're not picking anything random whatsoever. Check out this imagery. What is that, you wonder? Well, that's Venus in Solar Orbiter's recent flyby. So you can see the date stamps up there in the upper left. Sadly, the Solar Orbiter expected to see some nighttime features, but the daytime side is so bright they were not able to be resolved by the imagery from the Solar Orbiter. So this is another SciTech Daily article returning to where we started in today's cosmology segment, which was integrated in the daily space weather video. Solar Orbiter catches Venus glare during close pass of our solar system's hottest planet. Yeah, Venus, it's even hotter than Mercury. I'll just let the article scroll here. Again, this was from scitechdaily.com. And again, don't forget to check our playlists. We got lots of videos that have nothing to do with space weather. Is there an overlap between space weather and cosmology? Leave us a comment. Let us know what you think. All right, and let's blast through some more data here. We don't see any charging hazards right now. Here's the electron flux over the past year, and we see more nominal levels of electron flux. Here's the 3-day chart, and you can see we are in a more normal electron flux range here with the subsiding of that coronal hole wind stream. Here's the forecast model, and you can see NOAA and I agree here. There's going to be a continued uptick in the electron flux. We may get into warning levels and see some communications breakdowns as a result of it, as satellites shut themselves off in what we call a CCD bakeout, where the charge coupled device shuts down to prevent its own damage. Here's a diagram of Earth Van Allen belts and distances in miles to objects. Here's the total electron content forecast showing the whole air column and the electron density therein. Attempting to interpolate all of the electrons between your GPS handset and your GPS satellite. No anomalies showing up here on the total electron content forecast. We're also going to show you the ionosphere. Here's another diagram of the atmospheric distances here in kilometers. So here's a visualization of the F ionosphere layer courtesy of the Australian Government Bureau of Meteorology. And it looks like some low-frequency anomalies once again happening here around the South Polar region. And of course, our favorite anomalous spot, the South Atlantic anomaly, now over the South American continent, perhaps should be named the South American anomaly. But in any case, since it's not in the Atlantic anymore, but in any case, here's the latest image. That's from 10:30 Universal Time. And we see some anomalies over northern North America once again. Here's the anomaly map to give you a better visualization in case you don't look at this every day. Thanks to our viewers who do, we're attempting to tie together a lot of pieces of data here and increase people's understanding of the relationship between space weather and Earth effects. It's part of our mission. And if you want to read more about that, head to smashomash.com/forum/ mission. Links in the description to all kinds of stuff about what we're up to besides making these videos. Here's the latest image. And again, you can see those anomalies we just referred to. I'm used to looking at the ionosphere map. We hope you're getting used to it as well. That image from 10:30 Universal Time also. By the way, today we'll feature a meteorology segment as well. Make sure you check that out if you haven't yet. There's a playlist for it at youtube.com/smAsho/playlists. And we just completed another fantastic meteorology segment, so make sure you check that out. We're going to do some bonus features, starting with the Learmonth, Australia Solar Observatory. So here's the latest imagery from that. Let's zoom out a little bit so you can see this is 1 hour and 32-minute old data. At that time, at least, this filament and this filament were both still intact. Coronal mass ejection remains in effect. Solar flare watch goes down a little bit here with the degradation of sunspot 2857. Here's some additional imagery for you. The GOES 16 SUVI imagery. And this is showing more filaments than I actually have confidence in. I think there are some coronal holes here that aren't really showing up very well. When there's a lot of plasma in between the Earth and the Sun, it messes with the sensing. Lots of prominences here around the eastern limb. Again, coronal hole watch in effect. Here's the latest intensity gram, and you can see the degradation of this leading umbra here, sunspot 2857. No other sunspots on the Earth-facing portion. There is some active region rising down here in the southeast, and it does not appear to have any umbra. So not a sunspot, just a plage. And do we have a sunspot forming down here? There's a new sunspot. So there's sunspot 2858. That'll likely get a name. It has the capacity to be on the solar disk long enough. It looks like it's alpha class. I only see one polarity umbra likely associated with that, and maybe growing another one. And that could produce some solar flares. So let's close this thing out. Here's the SDO imagery, close up, as close as she gets, to sunspot 2857 and 171 angstroms. And here's another iron emission state, 94 angstroms. And once again, thanks for tuning in to The Daily Space Weather. Congratulations on realizing that our channel exists, and may that solar wind be at your back.